Hi everyone. So we'll be looking at even and odd signals for today. Now the first definition, let us take an discrete time signal x of n. It is said to be even in nature if x of minus n is equal to x of n. This is the discrete case. Now let me take a continuous time signal. If x of minus t is equal to x of t, this is for continuous time. If x of minus t is equal to x of t, then if these two conditions are satisfied for any signal, it may be discrete or continuous, then that signal is called even signal. Now, on the contrary, if x of minus n is equal to minus x of n and x of minus t is equal to minus x of t, then if the signals satisfy these conditions, then those signals are called odd signals. And I presume that you know this. This is for a discrete signal, this is for continuous time signal. Now let us find a way to derive an equation for even part of a signal and odd part of a signal. Now let me take any signal, say for example continuous time signal x of t. Now we know that each signal has its own even part as well as odd part. So let me take this as equation number 1. Now if I replace t by minus t, I get x of minus t is equal to xe of minus t plus x odd of minus t. Now we know that since the signal is even in nature, as from this x of minus t is equal to x of t, so xe of minus t will be x even of t, and we know that for an odd signal x of minus t is minus x of t, so this would be minus x of t, x odd of t. So let me take this as equation number 2. Now if I add and subtract these two equations, I'll get equation for even part of the signal or odd part of the signal. Now if I do 1 plus 2, on the left hand side I get x of t plus x of minus t. On the right hand side I get 2 times xe of t, whereas the odd part of the signal gets cancelled, right? So you get expression for even part of the signal, that is x of t plus x of minus t divided by 2. Now if I subtract 2 from 1, I would be getting x of t on the left hand side, x of t minus x of minus t is equal to, this even part of the signal gets cancelled, so odd part of the signal xo of t minus xo of t, it will add up, so you get 2xo of t. So finally you get an expression for odd component of the signal, that is x of t minus x of minus t divided by 2. So only the change is you take the signal, you take the reflection of it, you add them and divide by 2, you get even part. You take the signal, subtract the reflection from it and divide it by 2, you get the odd part of the signal. Now this derivation I have done it for continuous time signal. This derivation holds good for discrete time signal as well. So I can directly write xe of n as x of n plus x of minus n by 2, and x odd of n is equal to x of n minus x of minus n by 2. So this is an expression for finding even and odd part of a signal if the signal is discrete. This is for discrete and this one is for continuous time signal. Now, given x of t, plotting x of minus t and other things we'll be discussing in the next lecture. So for now, what we have understood from this derivation is any signal can be represented as a sum of even signal as well as odd signal. So even part of that signal is got by this expression and odd part of the same signal is got by this expression.